Hello everyone. In this video, we will be learning about development of surfaces. So in order to understand development of surface, you need to know the what is the projection of point, projection of a line, projection of a solid, and section of a solid in order to understand this development of surfaces. So generally the term surface means it has length and width, and the thickness is negligible or very small thickness it has, then we call it as a surface. So this surface is generally used to roll. We use these surfaces whenever it has an internal any hollow thing, then we call it a surface. We can't consider it as a solid because solid is three-dimensional, but here it is also three-dimensional, but the third dimension is very negligible, very small, in very small unit, so that it is negligible, and you won't be considering this third dimension, you won't be considering in the surfaces. Okay, so yeah, that's the main interaction between surface, and general surface might be hollow, and it will not be generally as a solid. It will be a little bit hollow in nature. Okay, so here we can say that development of surface, we can take a plain sheet, and if we fold the sheet in a proper folding, and it can be converted into desired object. You are taking a plain sheet and you are folding into desired object. Suppose I'm making 1, 2, 3. So this is a like A, B, C, D, and again A. And at the top of here, I have a one more square. At the bottom of here, I have one more square. So this is just like a plain sheet. I'm cutting the plain sheet. Sheet already you know at a normal paper. So you can take A4 size paper, and the thickness is negligible for that paper. And this will be, you can at the top you can write as 1, 2, 3, 4. Again it will be coming as 1. So this is 3, so it will come as 4 and 1. So this is D, this is A. So it comes as B and C. Okay, so this is a normal A4 paper. So on this A4 paper, I'm drawing this one. I'm making the cut 1, 2, 3, 4. At the top, I'm cutting. This is the portion. I'm folding the paper, and this is the paper I'm making. These things are removed. These things we don't have. Then it will become as this shape. And if I fold in proper way, then what happens is it will become as a square prism. Okay. So if I fold in a proper way, it will become as a square prism, and inside it is hollow. It is not a solid, and inside it will be hollow. Okay, so you can take a normal plain sheet, and with respect to the foldings, you will be getting as the different shapes you can generate by the surface. Okay, so suppose this is a surface, this is not a solid, this is a surface, and here what I'll do is I'm cutting at this portion, I'm making this into two halves. This line, this vertical line, making two halves, so that there will be two A's and two ones. So A is repeated once again and one is repeated once again. Okay, and I'm making, so here I'm making sure that I'm leaving 2 to 3 line. I'm leaving, I'm cutting the all the line, 1 to 2 line I'm cutting, 1 to 4 line I am cutting, and 4 to 3 line I am cutting. Okay, these three lines I am cutting, I am leaving 2 to 3 line. Then this is attached to this one. And similarly here I am leaving AD line, I am cutting AB line, BC line, and DC line. Then only AD line will be there. If I make it this one, this will convert into this one. Inside it is a hollow, it is not a solid. Okay, it is a prism of surface. Okay, then you can make different thing. So example of a surface, you can call it as measuring flask. If you take a measuring flask, so like uh, you can see any measuring flask. Suppose like you have a measuring flask. So if you are in the any of the uh, chemistry work, chemistry lab, if you have seen, you have some measuring flask you have, or else like this thing, you have any of the tube to measure the what is the volume of the liquid you measure. All these are measuring flask. This is example of surfaces. Example is chimney. Okay, so chimney is uh, like if you see any outs of the restaurant or anything, they'll have some chimney, so that it is like also surface, it is a hollow in nature, so that the gases will pass through this one and it will pass. Okay, so this is also one of the example of the surfaces. And if you see the any funnel, so where whenever we want to, whenever we are making any whenever we want to transfer any of the thing, we'll be using a funnel. So funnel will be like this, sometime it will be like this. So to transfer liquid from one bottle to another bottle, we use a funnel. So it is also example of surface. It is not a solid. If it is solid, the liquid can't pass through inside. Okay, if it's a measuring flask, we can't pour and store the liquid inside the measuring flask. Okay, so these are the different examples of the surfaces. Okay, so methods of development, there are different types of method of development. First is a parallel method. So what are the lines you are drawing? All the lines are parallel. So initially I have shown this example, all these lines are parallel, so it is a parallel method. And in this case, all the edges or generators of the lateral surface are parallel in each other. Okay, so what are the same thing I have shown? All these lines are parallel to each other. This is called lateral surface. Okay, this is called lateral surface. And if you are not drawing the above top view or bottom view, if you are not representing these things, it is called as a lateral surface. Okay. And next, development of prism. So one of the, again, parallel method is divided into two types: development of prism and development of cylinders. So here we will be dealing with development of prism. So first, front view and top view of the prism are drawn. So whenever you see any development, you have to draw the top view, top view and front view. Suppose you have taken the XY line. Suppose you have taken the XY line. So they told that any d distance of around 20 mm, and this is projected here. And with respect to this one, I take an axis height and I'm drawing this one. Okay. So this is first I need to draw the top view and front view of the object. Then I can make the projections. Then I need to extend this one. Then I need to take, this is my distance, lateral surface distance. I'll tell you how to calculate this lateral surface distance, and then make the division. This is one side. So measure this side and cut, and measure this side and draw the line, measure this side and draw the line. Okay, so like this you can able to draw this development. Okay, then these are calculated by the perimeter. You need to calculate the perimeter. Suppose if you are taking a circle, you have to calculate the circumference of circle. If you are taking the any prism, if you're taking the prism, like if it is a triangular prism, so you have to take the perimeter of triangle. If it is a square prism, you have to take the perimeter of a square. If it is a pentagon, you have to take the perimeter of the pentagon. So like this you have to make this one. Stretched out lines are drawn by the ends of direction in perpendicular axis. So this is my axis. So this is the stretched out line. The stretched out lines are perpendicular to, this is a 90 degrees and this is a 90 degrees. So these stretched out lines are perpendicular to the axis here. Okay. So example, this is a prism and it has length, width and thickness. So that if I want to, this is my surface or any sheet. You can consider it as sheet also. This sheet, if I want to make this as this one, to store anything, to store example, to store any nails inside it. So like this we can use by using this one. Okay. So similarly, if you want to make the development of this triangular prism, so here we will be cutting the object here and we'll be getting the shapes, only 1, 2. Then these are the 3 things we'll be getting. So this will be the perimeter of the triangle. Similarly for hexagon, you have to take the perimeter of the hexagon. Okay. And there's a form. Okay, there's a formula how to calculate this one. Okay. Then development of cylinder. So in the development of cylinder, it is equal to the circumference of the base circle. So whenever we are making the development of 4 cylinders, it is equal to the circumference of the base circle. We can develop the cylinder. So like this, suppose this is the diameter. This is diameter and this is the height. Okay, this is 3D. This is not the exactly top view, front view. So it is a 3D object. For 3D object, this is the height and this is the diameter. Then from with respect to this one, with respect to same height you have to take, and the circumference of circle comes as 2 pi r, 2 pi r, and 2r equal to d. So here we can write it as pi d. So here we can make it as pi d. So this distance is pi d, and this suppose the distance comes as 157. Suppose the distance comes as 157.1 example, and you are divided into 12 equal parts. So what you have to do in this lateral surface development, so you have to divide again into 12 equal parts, and whatever the maybe the distance, you have to cut the distance. So sometimes it may be equal. Last one may be either more or less, so no need to worry about it. Last one you can leave it. So it may not be equal divided with the compass also. Okay, so make sure that you are dividing it to, because you have some more decimals here. After one you have some more decimals, so it is difficult to get the exact value. So last one will be either more or less, so leave it and give the labeling a b c d e f g h I j k l. After that you will get 1 again at the top, 1 2 3 4 5 6 7 8 9 10 11 12, again it will be 1. Okay, and again this circle also you have to divide into 12 equal parts. This circle also you have to divide into 12 equal parts, and here you have to mention the diameter. What is the diameter you have to mention, and here you have to mention the what is the pi d and value of pi d. Example like 157.5. Okay, like this you have to mention in the exam. Next, perimeter of triangle a plus b plus c. So what is the distance of a? Suppose it is a prism, so it is a equilateral triangle. Suppose the distance is 30 plus 30 plus 30. Okay, total will be 90. So perimeter of circle or circumference of circle, we can call it as circumference of circle, 2 pi r or pi d you can calculate. And perimeter of rectangle, suppose the shape is a rectangle, so this is a rectangle. So what we do is 2 into length into width you will be taking. This side we won't be considering. 2 into L into B, width into height, width into length we will be taking. And for any polygons like pentagon, hexagon, octagon, for any polygons, n into side. Suppose it is a square, we make it as 4s. It is nothing but 4 into side. Similarly for hexagon, it will be 6s, 6 into side. Suppose the side is 30, 25. Based on this one, you have to make this one. Perimeter of a cube. The cube has 12 sides. The cube has 12 sides because this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So cube has total 12 sides. So you will be having 12 into sides you have to make. Okay. Next is the radial line method. Previously you have learned about parallel line method. Now it is a radial line method. So this is mainly used for the, if you have any cone you have, or else you have any pyramid, square pyramid, pentagon pyramid, hexagonal pyramid, then you have to use this radial line method. So here you have to consider with respect to the slant edge. If it is a cone, you have to consider the slant edge, and a slant edge for the cone and pyramid you have to consider the slant edge. For development you have to consider this one, slanted you have to consider. So first one we will be learning about cone. Next we will be learning about development of pyramid. So cone, so everyone, I hope everyone know the cone. So this is a circle. From the center you will give the apex value. From the apex it will be joined. Okay, and whenever you see this one, this is the length and this is the right angle triangle. So this right angle triangle, if I rotate, it will become as a cone. If I rotate this right angle triangle into 360 degrees, then it will be generated as a cone. And if you compare the length, this height may be, example, the height may be 50 mm, and this slant height, this is called slant height. This slant height will be definitely more than 50. Suppose it is 65, example. Okay, so example, this is 50, it will be more than this one because it is a slant. If this slant height, if I make it vertical, it will be 65 and the axis will be 50 only. Okay, so here we need to calculate the slant height. This slant height is represented with the L, 65 equal to L, and this 50 equal to height. This 50 equal to height, this slant L equal to 65. In exam, if they give that axis is 50, then you must compulsory get the L slant height compulsory greater than 50 because it is a slant height, it is an inclination. If I make this inclination vertical, then it will be more length. Okay, So here you have to calculate this slant height. You have to calculate, and L is the radius of the sector of a circle, and you have to calculate this sector of circle R. Okay, if you see the figure, you will understand. So yeah, if this is the this one, this is the radius. This is the radius, and this is the L you have to know. Then only you can calculate the formula. This generally this slant height L is, you can in some textbook it is represented as capital L. In some textbook like ND, but it is represented as capital R. So you can either represent as a capital R or capital L. Anything is correct in the exam. Okay, so now we have to calculate what is the L. You can directly measure with the if you have already drawn, you can directly measure. If you do, if any mistakes is there, you can directly calculate what will be the L. Directly by calculation you can know. So this is a cone. You have to know what is the R distance and what is the H distance. This is my vertical is the H distance. If in the problem they gave these two things, that you can calculate what is the L. So this is like a Pythagoras theorem. This is like a Pythagoras theorem. So we know that Pythagoras theorem, suppose this is 4 and this is 5, then we are calculating this one. So this question mark equal to square root of 5 square plus 4 square. So this will be 5 square plus 4 square, just like Pythagoras theorem. So we are calculating this slant, okay, or hypotenuse. We are calculating this hypotenuse, and it is nothing but 4 square plus 5 square. So it is nothing but this is the vertical height. So this is R square plus H square, under root of R square plus H square, because this question mark square equal to 5 square plus 4 square. So this square I'm sending this side, so it will become a square root. So it will become a square root of R square plus H square. And here we have to find the theta. This is the angle theta. What is the total angle? We have to find the theta. So if I expand, if I cut one portion and expand, so this will be the theta. So based on theta only you have to make the expansion. So this theta is calculated as small r. This is my small r. Don't calculate the slant height. This is my small r. Small r divided by L and multiply by 360, because it is at an angle of 360. It has rotated completely 360 degrees. So you have to multiply by 360 degrees so that you will get the theta value. Suppose the theta value comes as 138 change. Suppose this theta value comes as 138.7 example. So what you have to do is, already you need to draw this one. You need to measure this length. What are the length you draw? So I will draw once again. So this is your circle, and this circle is projected here, and from this one we are drawing the apex, and we will be joining the apex. Okay, then in some textbook what they do is they draw the parallel lines, draw the horizontal line, and they draw a parallel line to this one. They draw a parallel line to this one, and they take an angle of 138. They will take an angle of 138 and they will join, and they will directly join this point. And here you have to take the angle of what are the angle theta, and this theta again you have to make it, you have to divide it by 12. This theta you have to make it, and you have to divide it by 12. So you have to divide by 12. This theta you have to divide by 12, and you have to mark the points here. Suppose 10 example, suppose 10 10 10 I'm marking. Then I have to extend these lines. Then I have to extend these lines. Okay, then I have to extend this line, and I have to make at one point I have to draw extend this line, and I have to draw the circle. At one point I have to extend, and I have to draw the circle. Okay, so this is the main explanation. In some cases they'll tell like this, or else if you know the directly the what is the length, you know, then draw the vertical line. This vertical line, suppose this axis is 50, this H is 50, and this L, capital L, you have calculated it as 65. Then draw this vertical height 65, and from here you have to take an angle of 132. Suppose what is the 138 degrees, 138.7. Then join this one, and again keep your protractor here, mark the divisions, divided by 12. Suppose the divided by 12 comes as so if you're dividing by 12, it comes as suppose 11, example 11 degrees. So 11, then 22, 33, 44, like that. You have to mark the points, and then you have to join. You have to join all these things. Then you can generate this shape. There are two methods. Either you can draw the parallel line, already you have a slant height, then you don't need of calculating this one, directly you can draw this slant height. But for theta, you have to know what is the L value. If you are calculating theta, you have to know that R into L by 360 you have to calculate. So that is the compulsory. So better to calculate the L, this L value, R square plus H square, or else directly you can measure with the scale. What are the measure? If you don't have a calculator, directly measure with the scale, and you can directly place this value. This R will be given in the problem. So you can get the approximate value, that value, that degrees you will be getting. That degrees you can divide into 12 equal parts. Okay, where H is nothing but axis height of a cone. Capital L in some textbook, capital R in some textbook, it is called as slant height of the cone, where small r is the radius of the base circle. Okay, this is about the cone. Next is the development of pyramids. So in the development of pyramids, we have to develop the lateral surface of the pyramid, consists of series of isosceles triangle. So if you see the pyramid one side, if you are seeing, suppose this is a triangular pyramid, or else you can consider it as a square pyramid. So I'm considering a square pyramid. So this is a isosceles sides, because these two are the same distance. These two are same distance, and this is another value. This unit is suppose this is 30 mm. This is around 40 or 45 mm is the slant height. So this is isosceles triangle. The sides you have to draw these isosceles triangles here on this. If you are making development, you will get an isosceles triangles. The true length is a slant edge is need to be determined first. First you need to calculate what we need to know what is the slant edge, then you have to start. So this is a pyramid, slant edge that you can measure with the scale. After drawing, first you have to draw like a square here, and from this square you have to make the projection. Then you will draw the like this you will be drawing. Okay, then this is not the true length, this is not the true diagonal length of the square. So for getting the diagonal length of the scale, you have to extend this axis. You have to find this center, find the center of this square. Then you have to extend this square, extend this axis line horizontally. Then this is the radius. Again you have to cut wherever it is cutting, mark the point as H or M. So I'm marking it as M. This will be M dash. This M dash should touch this one. This is the actual slant length L. This is the actual L, whatever represented, this is actual L. Because in the front view, what happens is the length is reduced. Because we gave some angle, the length is reduced. If you want to see the true length, you have to take an angle of 45 degrees. So to take angle of 45 degrees, it will be shape of a square, will be like a rhombus. It will be like this. So that's the reason these two corners should touch. So that's the reason this axis, we are extending this axis, and with this radius I'm cutting, so that I'll get this point. This is my actual true length. Okay, so with respect to this one, I have to draw a line, I have to draw the parallel line. Similarly, I have to draw the parallel line, and then I don't know where it ends, draw the arc, because here we can't calculate theta, but we know this distance. Suppose this distance is square 40. Suppose this distance is square 40. So with respect to 40, I'll take an arc and cut 40 distance. Then I can directly join this one, so that I'll get a square pyramid development, lateral surface development of square pyramid. So here I can write A, B, C, D. Again I will be writing A, because this one this A I'm cutting, so that A is divided into two parts. A and A, you get the same labeling. Okay. So here we don't know what is the end of the arc. We draw a arc completely. We don't know where it ends. Then we take a, with the compass, we take an this B distance. What are the distance of a square? We take the distance, we cut. We cut 4 times, and then we join them. Okay. And again bottom, again you have to draw a line. This is a arc. This is a arc. From this arc, again you have to join the points A to B. We have to join B to C. We have to join B to C. You have to join. First we have to join A to B. Next B to C, C to D, and again D to A. We have to join all these things. Okay. Then you erase this extra arc. You have to erase this extra arc. Then you can develop the pyramid here. Okay. Similarly, if you are developing a frustum of a cone, so already we have learned the cone. Frustum is nothing but already we have slant L. Suppose this slant L is 65. So from the apex, I'm cutting the distance at a distance of 35. Okay, so normally we have to develop the same cone, draw this cone. So this is a cone, this is a slant height I will get. So with respect to this slant height, I'll draw a parallel line. With respect to this slant height, I'll draw a parallel line. I'll calculate theta, I'll draw the arc. Theta ends here, join the theta, divide into 12 equal parts. So I'm dividing, suppose I divide 12 equal parts. Now here I'm cutting parallelly. So I'm cutting parallel. So this point, whatever may be this point is also same, I need to cut here. So measure this point, draw the arc. Arc completes, and this side I have to draw it light, and this is my actual shape. What are the cut portion are there? We will be removing the cut portion, and this will be the portion will be there. Theta is same for both the cut portion. This is my L1 distance, and this is my total L distance. Okay, so this is also same formula. Capital R, we can consider not capital R, we can write it as small r by L into 360. It is r is nothing but you can write it as small r. Small r equal to base radius of the cone. So this is my r, half of the circle, radius of the circle, half r, and this is my total slant height, and this is my cut portion. Whatever I'm cutting, this portion is removed. Only this circle will be there, and this circle, if I divide, suppose I draw a line, divide into 12 equal parts, then at this one I have to give this small circle radius here. I have to give small circle radius. With respect to this radius, I have to draw the circle. Again, this is a complete r. This is small r. With respect to small r, I'll draw the radius, and with respect to this radius, I'll draw a circle. Okay, I have to divide all this in. So this is about the frustum. Anywhere we are cutting the portion, then we'll be using this frustum here. And the inclination, the cut portion can be inclined also. It can be inclined also at an angle. Suppose for this cone, they say that at a height of 35 mm, the inclination is at an angle of 35 degrees, 45 degrees, or else it is bisecting the axis. From the bisection of the axis, the angle is 45 degrees. Like that, they can ask any in the exam. Okay. So next one is the development of frustum of the square pyramid. So similarly, you have to draw the pyramid. You have to take the pyramid. You have to take the slant height, actual slant height. So same. This is your square. For this square, I am drawing this one. I take the radius, and from here I am making the projection. From here I'm making the projection. I'll get the true length. With respect to this one, I have to draw this line, and I have to draw the arc. I don't know where the arc ends, but I know this square distance: 40, 140, 240, 340, and 440. Then I'll join all these things. So this square pyramid is generated, and I have to erase this extra lines. Then it is cut parallelly. Frustum is nothing but it is base is cut section is parallel to the base. So with respect to this distance, I have to mark this distance, and then I have to draw the arc. Same arc. I have to, this will be the radius. I have to draw the arc, and again I have to with respect to your scale, small scale, join these lines. Join all these lines. Again join this line, this line, this line, this line. Join all this line, and you know this square, and you know this square distance. So with respect to the square distance, draw the square here, and you know this distance. This distance you know. Suppose this distance comes as around 15 mm. So extend this 15 mm, draw the 90 degrees, draw the 90 degrees, extend this one. You can draw the square at the top and bottom, because when I'm cut here, I get a bottom square here. I get a top square here. Suppose the bottom square is around 15 mm, top square is around 30 mm. So here I have to extend. Already this is a 30, then I have to draw the 90 degrees lines. 90 degrees lines of 30 mm, I'll draw a square. Suppose this is 15, I have to draw a 90 degrees of 15 mm square and join them. You will get the this one. I hope everyone understood.